So we have cos 3x, yeah?
Yes. We can choose to expand this
Okay,
negative
first again we say because we have cos which is equal to cos, so we're going to have 3x
equivalent to
and then we have
90
90, yeah,
minus x
plus
30.
plus 30.
The positive 30 and minus x, we got it because of the negative outside the bracket. This is going to be multiplying inside.
Okay, sure.
Yeah. So having like terms 90 and 30.
So
it's
we have
going to be
3x is equal to
120 minus x.
120 minus x.
So we can take the minus x to the other side.
No,
Oh,
we
not
don't.
h. Oh, so yeah.
So we have our ref angle. The code is to get the ref angle, yeah. Yeah, so we got the ref angle.
Okay.
Sure.
I told you.
Okay, so we have the ref angle. What should we do with the ref angle? I think that is why I was saying to you, we need to decide where we are going to work first. So we've decided this is where we're going to be working. We're going to work on the first quadrant, and then we're also going to work on the fourth quadrant. How do we know that? We said where sine is going to be, where cos is going to be positive. And then the question that I usually get is that, can I say sine, where sine is going to be positive? No, left-hand side in relation to the right-hand side. So cos is the boss here because it's on the left-hand side.
Oh.
And then we are asking everything in relation to cos. We're saying, where is cos positive?
Okay.
As much as we have the sign, but we're asking where cos is positive.
So yes, I
Yeah, sign is the boss. Where is sign going to be positive? Okay, so we have the first quadrant again.
Yes.
First quadrant. According to the first quadrant, what will you say then?
I'm going to say first quadrant to take the ref angle as it is.
You take the ref angle as it is. So you're going to have 3x on it.
Yes.
Which is going to be
120
minus x plus
300. We're dealing with cos, and then cos is 360. So
k multiplied by the period. Ne?
Yes, the period of the cos is
360. Sure. Then that's when you can start to work.
Oh,
you work, yeah, on the quadrants that you're working on. Then that's when you start to transpose.
Oh.
Is that clear, everyone? To everyone, guys? Yeah, you're
Yes.
asked.
Okay, so what if now I decide to transpose the x?
Yeah, you would see it will be wrong.
Okay, yeah. Wrong.
There are instances whereby it can be right. I've seen instances whereby it can be right, but more often than not, it's wrong.
Okay, to be
because here's why you'll see here. We have to divide somewhere. We'll have to divide the period.
Oh.
So if when are you yes, Mr. Mashita?
No, sir, I don't find this clear.
Mashita? Yes.
Yeah, Mr. Nagno Bushor. Oh, nyaka reference angle. About no transpose.
You're asking this question that Khoto was asking to say, can I transpose here from the ref angle here?
Yes.
No, you can't transpose from here.
Yes.
You don't transpose from here. Here you leave it exactly the way it is. Yeah, so you just say which you have 3x, which is going to be equaling to 120. Yes. Yeah, minus x. Yeah, you take it exactly the way it is, because it can be affected when you start to work on the first quadrant and on the fourth quadrant. Is there any other person? I heard another voice. You wanted to say something?
No.
Oh, you're fine. Okay. All right. So we are moving on then. So we don't transpose on the ref angle. Okay, and then reason why it can be, other instances it can be right, other instances it can be wrong. So to be on the safe side, we don't transpose them. Okay, sharp. And then from here onwards, what should I do here?
Oh, now you should transpose the x to the other side. So I'm going to have 4x equaling to 120.
It's equal to 120
plus 360k
plus
k360
k 360. Ne?
Yes. Then you divide by 4.
Divide by 4.
Divide by 4.
Divide by 4.
So we're going to have x.
We're going to have x
equaling to
30.
30. 30. Then plus 90. Yeah, 90.
K multiplied by 90. Ne?
Yes.
Are you sure?
Yes.
Yeah.
So,
okay.
I didn't understand the first part.
Okay. It's who?
Why did cos 3x is equal to sine x minus 20 degrees change into cos 3x is equals to cos 90 minus x?
It's Oh, yeah. Let's look at this. Tiago, are you still here? Tiago?
Yes, sir.
Okay,
Sir.
so you are asking, how did we change this sign to become this? That's the question, if I'm getting you correct. Tiago? If that's what I'm understanding by your statement, then I will then say the reason why we're able to change this is this. If I give Elena something like this, let's say I give Elena the sign of 2x, and then we are going to use reducing angles. Remember, we have reducing angles, and then we also have co-functions. So if we have co-functions, then I can ask Elena, what is going to be the cos of 180? Let's start with something simple, 180 minus 2x. Now, the learner will say to me, say 180 minus is in the second quadrant. And then the learner can say, on the second quadrant, we have all students take coffee. They will say, sir, on the second quadrant, cos is negative. Okay? So this thing here, another way in which you can write this thing, which is allowed, it can be written as the cos of 2x negative, because cos on the second quadrant is negative. But if a learner is given something like this, then let's suppose the learner is given the cos of 90 minus 2x. Now, 90 minus 2x, where do you find 90 minus 2x? You find it on the first quadrant. Yeah? If you find it on the first quadrant, you will ask, is cos on the first quadrant positive or negative? Then we say, cos on the first quadrant, all of them, they are positive. Yeah? So because 90 is a reducing angle, it means this thing here, 90 and 270, they have the ability to reduce and change a trig ratio. So if it's cos, it's going to become sine. So I'm going to write this thing as the what? As the sine of what? Of 2x. So 90 minus 2x and the sine of 2x, they're exactly identical. Just like here. Cos of 90 degrees minus this angle here. This thing is one thing here. We can regard it as one thing. 90 minus this is going to be equaling to the sine of 30 minus. It's going to be equaling to the sine of x minus 30. This one and this one, they are exactly identical. So this one and this one, they are identical. It's just this one was useful. This one was not useful in this particular case. So we changed this and then we wrote it in a useful way. I'm not sure if it makes sense here, if that was the question, because I didn't get the whole question. Diego? Diego.
Sir.
You get what I was saying there?
No, I'm lost.
You're still lost. Why are you lost? You still remember reducing angles?
Yes.
You still remember reducing angles?
Yes.
Okay, let's jump here.
Yes.
Maybe it will make sense. Let's come here. If you still remember reducing angles, maybe let's do this. I have a question that I wanted to give you. Okay, let's check it. It's here, KZN. Look at this then. You remember this question here, this type of a question, this one?
Yes.
You remember this?
Yes.
Tiago?
Oh.
Tiago, are you there? Okay.
Yes, sir, I can see.
Oh, you can see. Yeah. Remember, this question, we are reducing, remember? Ne? And then if we are reducing, this thing here, I can write it as what? Let's look at this. I'm just going to take this 180 minus beta. Ne? Let's look at it. So this thing can be written as what? 180 minus beta, which is sine. What is the equivalent of this? The equivalent of this is going to say, let's go to 180. Where do you find 180 minus? You find it on the second quadrant, Angish.
Yes.
So, on the second quadrant, what should we say about sine? Is it positive or negative?
Positive. Positive.
Positive. Yeah, so this is going to be written as the sine of beta. So you see this one. This thing and this thing, they're exactly identical. Yeah? These two things are exactly identical. It's just this one. This one is reduced. This one is the longer version because 180 can reduce. So here, here's what I'm saying to you. I have cos, I have sine. Do you see that?
Yes, I can see.
Yeah, I have cos, I have sine. If I have cos and then I have sine with different angles, I have 3x, I have x minus 30. It's a problem, this thing here, because I'm dealing with cos and then I'm dealing with sine. But I know something from reducing angles. If I were to reduce this, let's look at this here. Let's say I say to you, you have the sine of 90 minus x or beta. Let's make it x. So if I say you have the sine of 90 minus x. Now you're going to ask 90 minus x, where do you find it? First quadrant or second quadrant?
First.
First quadrant. What do you say about sine on the first quadrant?
It's positive.
It's positive. Yeah, but since it's 90, it reduces and then it's also going to change our sign. Ne? So instead of sine, this thing here is going to be written as the what? As the cos of what? Of x. Does that make sense?
Yes.
It doesn't.
It does make sense. Ne? So both of them, these two things are equal. This one and this one, they're equal. Both of them are equal. So if I don't want to write it as cos x, I can write it as the sine of 90 minus x. It depends which one is useful. If they said I should reduce, I will write it this way. Here, I have a problem here. What is my problem? I have cos, I have sine. Ne? Since I have cos and then I have sine, I can't deal with cos and sine because the angles are not the same. If the angles were the same, I could try to do it using tan. But since the angles are not the same, I should change this sine to become cos. How do I change this thing to another way? It's like I'm saying to you, write this thing in another way. How would you write this thing in another way? Let's take this one, for example. If you are given the cos of 2x, I say write this in another way. What is the other way of this thing? And then which will be useful? Because there are many ways, but we want one which is useful. No? Let's not make it 2x because it can be a double angle compound identity. Let's make it to be 3x. So if I give you something like this here can be written as, in another way, it can be written as the sine
Of
90 minus 3x.
Minus.
Yeah. So look at this. If you were to reduce this thing here, you will say sine is on the first quadrant. What do you say about sine on the first quadrant?
It's positive.
It's positive. Yeah, and then it will take you back to this one. So this one and this one, they're exactly equal. So what we did in here was to change this sign and wrote it in a useful way. This was the useful way. We simply said it's going to be the cos. Because if I say cos 90 minus, I will say cos 90 minus. Cos on the first quadrant. 90 minus and she's in the first quadrant. What would you say about cos in the first quadrant? Is it positive or negative?
Positive.
It's positive, yeah. And then the 90 is going to more or less like disappear, and then you're going to be left with x minus 30. Ne? But it's going to be sine. Because it was cos, it's going to become what? Sine. Because of the 90. Is that fine?
Yes.
All right. Yes, what?
Maybe confuse your problem. This thing, I'm very sure this thing can be taken as an angle, like a single angle, maybe.
But you get that with this thing here can be written as one thing here. I can say if it's complicated for you, you can say let it be k. You can say let's try it this way, maybe. If you say let x minus 30 to be equal to k, ne? Meaning which instead of having this here, I can write it as something like this. I don't want to erase everything because we still need this. We are not done with the equation. So I can write it as the sine of k. Yeah, if I say let this whole thing here to be k, so it will look as if it's a single angle. Maybe the part which they've shifted the graph, it makes it a little bit complicated. So you can say let this to be k, and then you'll have something like this, the sine of k. And then how do you write the sine of k in another way? You need to introduce cos. So we're going to say this is cos 90 degrees minus k, like this. And then this and this, they're exactly identical, these two things. Is it fine now? Network. Okay, Tiago, let's finish the question, then we'll come back to it. You know, if it's still giving you a problem, let's try to finish the solution and then we'll just come back to it. Okay, so we have according to number one, we said according to quadrant number one, this is what we're going to have.
Yes.
We're not done.
Yes.
Because we're solving it in two different quadrants. So what is the next thing that we're going to do?
Oh, now we're going to be dealing with the fourth quadrant.
With the fourth quadrant.
Yeah,
Okay, let's
because
go.
cos is positive in the first and
Roman figure, I write it as what?
as IV.
IV.
Yes, IV.
Okay, so we have IV, yeah, okay. So
That's
we
a
have,
great R, man. And then
we take this thing exactly.
yes,
which is
the way it is, I'm going to have 3x is
Yeah.
equal to 120 minus 360 degrees, sorry, minus into 120 minus x. Or it's going to be like that.
Yeah, it's going to
Yeah,
be
minus
into
80.
ref angle. Like our ref angle is this part.
Yes, minus into 120 minus x.
Minus x.
Therefore,
Plus
K
multiplied
360.
360. Okay. This thing doesn't want to write it. When I go this side here, it has a problem. 360. Okay. So we have 3x,
Okay.
which is going to be 360
Minus 120
minus 120
plus x
plus x
equal to
plus
sorry, K
multiplied by
360.
360. Okay.
Yes,
Okay, we have 3x. Huh?
yes. We can transpose the x already.
We should transpose the x. Okay, we're
So
going
we
to have
have 2x.
2x.
Yes,
Okay. So we have 2x, yeah,
which is equal to 360 minus 120 is going to be 240.
it's 240
Yes,
plus k,
plus K 360.
260.
Then we divide by 2.
Divide by 2, divide by 2, divide by
We're
2.
going to have x
X,
is equal to 120, K 180.
k 180. né?
Yes. K
Okay,
is an
sharp.
element of all integers.
K is an element, I've already told them, K is an element of all the integers.
Okay,
yeah.
now as we say that K is an element of all integers, let's go start in the first quadrant again. So if we start in the first quadrant, so as they say, K is an element of all integers. What are integers? Integers are from negative until, yes, negative infinity until positive infinity, right?
Yeah.
Yes. So we're going to start with the smaller numbers. And let's quickly go.
And then remember, we're working from x is an element from,
yeah,
they said minus 60 up
is
until
to
we get to 108.
180, yeah. 160.
108.
60.
108.
Or 80.
Included, both of them are included.
Yes,
so
then.
included. Square bracket. 108. 108. Okay, sharp.
Okay, so
Yeah.
so firstly, Nanegera in a table form. I don't know, it's a long process that you will know that. So we're going to the first quadrant. I get the general solution of the first quadrant. So we're going
30.
to, yes,
Yeah,
we're going to have
plus,
30
yeah.
plus 0 first, which is going to give us
90.
90, yes.
90 is this pattern.
Yes.
And then we're going to say this is multiply. Put it inside the bracket.
Yes, multiplied by 0.
Multiplied by, let's start with minus 1.
Oh, start with minus 1.
I'm not sure. Let's start with minus 1. Why start with 0? I mean, you can start with start with minus
1. Yes,
start with minus 2. At least k is an element of all integers.
Yes.
Let's start minus 2. Let's say minus 2. So if we say minus 2 and then we say equal,
plus 90
I'm just writing this thing here, this part here. At least 30 plus,
yes.
and then it's the k, you can agree it can be 90k. And then we say, yeah, equals to, we get minus 150, which is not what we are looking for, because now we are looking for minus 6.
Yes.
So we can say minus 2 doesn't work.
Yes. We'll go to,
and then I will go to the calculator again and say, let's change this one and make it minus 1. I'll just say delete and then say minus 1.
Yes.
Minus 1 gives me minus 6.
Yes.
Do I accept that one?
Yes.
So I'll tell them x is equal to what? Minus 6. Yes.
In the bracket, take the corners.
The curve.
Yeah, we're not going to include 6. If it was a curve, okay. Next one, what can we try?
Oh, now going to try
0.
0, yes.
Link ke la mabana.
Eight.
We put 0.
Eh.
We get it.
We get 30.
Yes.
Okay. X is equal to 30 sharp.
Now we're going to try.
We're going to try
1.
1.
Yes.
Okay, let's put 1. We put 1.
Get 120.
We get 120.
Yes.
X is equal to 120. Okay. Again, we're going to 180.
Yes.
So we can still put another one. Let's try 2. It's too big, no? 10. We are done. It means we are done. Guys, do you get where I get these numbers? Everyone, is it clear where we get these numbers? About -1, -2, -3. Let's start with Jane. Do you still remember where I get these numbers?
Yes.
Jim? Jim?
Sir?
You know where I get these numbers? About -1, -2, -3.
No.
They're saying K is an integer. Ne? If K is an integer, you can start at any number. Like the goal is to make sure which you get solutions between -60 up until you get to 180. Ne?
Yes.
So we're going to just do a trial and error here. We're going to type this thing here. And then for K, we can substitute with any value. We can start with -3, -4, but you'll see others, they are going to be extreme. They're going to be so big, which they don't give us what we are looking for. Because basically here, they gave you a restriction to say which you should work from here to here. They are saying a learner should work between -60 up until they get to 180. Anything, let's say a learner get -70, we don't take that answer. A learner get 190, we don't take that answer here. So you just type it in your calculator. Agree you got your general solution. You see this
Yes.
part? You understand how I got here?
Yeah.
Yeah. So
Yes.
okay. K is a value that you can substitute, is an integer. An integer is negative and positive values, né?
Yes.
Excluding the fractions. So it's like you are saying all the positive and the negative natural numbers, whole numbers, yeah, whole numbers, yeah. The negative and the positive whole numbers. What?
Mr.
Yeah.
Mr. Ka hore ke a bona hore le berekisitse first quadrant, Mr. Ne ko ba reng ke be ke berekisitse.
No, we're not done. We use the first quadrant. After using the first quadrant, now we're going to use the fourth quadrant. Yeah. So we're going to check Gucci on the first. Usually you'll find Gucci the answers that you got on the first quadrant. You can also find them, but the answers that you'll find on the first, you won't find on the fourth. So now we go to this one. We're going to type this now. We're going to change the one. This one we're done. Angish.
Yes.
Now we're going to use 120. We use 120. You type it exactly the way it is. 120. Angish. 120 plus, ne? And then you say open bracket, ne? And then you say 108 multiplied by the values of K that you're going to put.
Yes.
Now you start anyway. Let's start with -3. If you say -3, let's check what you get. I'm sure you say -3 equals to, you get -400. It's out. Extreme. Now you can try, if you want to, you can try -1. Try -1. In give you -6, but we've already written -6. There's no need for us to repeat it again because we've already written it. Okay, let's try 0. 0. It gives us 120. So we take the 120. We accept it.
Yes.
And then if you say 1, obvious, you can see now this thing. If we say 1, look at this. If you say 1, you get what?
36.
It's
300.
Yes. Did you try -2? I don't remember us trying -2. Did you try -2?
Skip D.
Oh, let's try -2. It gives you -240. So this one also doesn't work. So it means what you are done. This is our solution. You see, when we use this one, you didn't get a data, but this one it also gave us what? Data. We are officially done with this one, guys. Let me come back to Diego. It was Diego. Okay, Diego.
So I'm still busy with